stage, we upgraded these to medium poly models and ran them through Substance Painter to create stylized hand-painted textures. We were also able to improve the render pipeline, which allowed us to work more on post-processing and particle systems.
For the programming general process, at first we really didn't know what we were doing, and we had a long list of things that we wanted to add to the game. So in the beginning, we had a very basic functionality of those things to the game, and then after we learned more about Unity, we were able to go back and polish some of the other things that we did really early on and make it look more like how we wanted it to look.
So now to take you through our pipeline for art. To start off with, Greg and I worked together on creating concept art for the environments. We kind of just leaned into our different styles, but they ended up coming together really well. We were going for the same sort of whimsical, magical look. So on the left, you can see a lovely drawing by Greg showing the part of the castle bridge leading into a forest. And on the right, I drew the join between the evening cliff and daytime clouds.
So for the car, we wanted like, a fantasy look that we were trying to go for with the setting of our track. So when designing the car, I tried to like, give it that fantasy look and that modern look that we see like in like other kart games like Mario Kart. And one of the big parts of the game was that in one of the levels or one of the areas, which is where the player would be bouncing from cloud to cloud, we wanted to give it that look that it can bounce from cloud to cloud. So while designing, I put mini blimps on the side to give it that look that it can do that in the game. And for the animals in the game, we first came up with them when we were trying to come up with obstacles for the players to dodge while racing. So we came up with two. Vivian came up with snabbits, which is a mixture of rabbits and snails. And I came up with pandadillos, which is a mixture of red pandas and armadillos. So like the design behind the snabbits was that players would have to avoid them while the snabbits were slowly moving across the track. And for pandadillos, they were supposed to be coming towards the player, forcing the players to dodge them. So that's how we kind of came up with these two ideas.
And so we included the snabbits in the final track, and we actually weren't able to implement the pandadillos just because we had too many other things to focus on, but we thought we'd include the concept art because it's cool. And now to talk about some of our art challenges. I think the main one was just maintaining a bit of consistency between hard surface models, such as the castle and the cart, as opposed to organic models like the terrain, the animals, and trees. And the second challenge was Greg and I were both new to Substance Painter, so it really took us a bit of time to work out how to use that program to create the textures. And eventually, we kind of just did this sort of flat, cartoonish style with some color variation for shadows and highlights, and that created this nice stylized look. And lastly, one thing we really wanted to do was to have multiple times of day so that every environment would kind of take you through a different time of day. And we didn't know how to do that at first, but eventually I realized that I could do that with post-processing, just shifting the colors and exposure. And as you can see here, this is what our final terrain looks like with just the gray model and wireframe. We have about 96K faces, and that's excluding props like trees and animals. So this is what our final art looks like. So to start off with, this is our castle bridge, and Greg created the model and I textured it, just going for that kind of simple, cartoonish look.
So for the trees in our game, I modeled about 3 unique like tree shapes, so that all the trees don't look identical. And with also that, we also, gave each tree like 3 unique colors just to add more variation. And one problem we actually had with our tree models at our first test was that since I created the leaves as 3D shapes, and because of that, they had too many faces, and it actually took up too much memory. But me and Vivian were able to work it out, so we didn't have that issue anymore. And Vivian modeled the cave in Maya, and then she also did the textures in Substance Painter.
And then moving on to our last two environments, we have on the left the evening cliff, and I modeled some floating lanterns to go above them to make it more magical. And then on the right, we have a series of clouds. So I just created, I think, about 7 different clouds, and I duplicated some of them and moved them around to make it seem more natural.
So on modeling these two assets, I did all the modeling in Maya. And the snabbets, they mainly consist of just 2 major meshes, which is the body of the snail, I mean the snabbit, and the shell. And for the cart, at first it was kind of complicated because I was making it one big shape, but as soon as I just decided to break it down to multiple shapes, it got easier. And then when I finished the modeling in Maya, I sent it to Vivian to bring it into Substance Painting where she can texture it.
Yeah, I think the cart especially had some tiny details that it helped reduce the poly count to just kind of paint those in Substance Painter, like the belt buckles on either side of the blimps, and also on the wheels, those nice little shapes.
All right, so let's get on the visual aspects and into how all those visual aspects interact. So this was programmed in C# because that is the default for Unity, which was our game engine that we used. It was the first thing that we needed to do was make our player car actually able to move around a track, which obviously this track evolved with time to give the artist their time to create those pieces of the track, so we can then design those separate components such as boosters and how those animal obstacles will interact with the player before the caves and forests are even completed. One of our first prompts was originally we would have the car fall off the map and the user would not be able to do anything. So what we did with that was that we had the car respawn when it falls off the track. We have certain set of points around the track to keep track of our progress. As for example, are we a quarter's way through the track? Are we almost done through our track here? And by respawning back at these points, if we fall beyond the scope of what we have, far beyond the scope of the track, we can then place it back, and then the player can continue on. So it's not breaking the game completely.
Another thing. Oh, you can go back one slide, Vivian.
Oh, sorry.
Thanks, that's okay. Another thing we implemented was the tutorial. It teaches the player how to play the game by showing pop-up instructions, and it waits for key presses by the player. And once the player presses the key that it tells them to press, it'll go on to a new instruction. And when we made this new scene, we had to make a user interface so the player could navigate between the main game and the tutorial. So this was the very beginning of our user interface as well.
Yep. In addition, we needed to be able to have the obstacles interact with the player, and the snabbits needed to be able to move around the map, move around the cave, which was very different from our original model, so we needed to make the snabbit move it flexible. What we did was create them into a nav mesh agent, which is able to navigate around the area automatically, as long as and place in a few invisible objects that we call waypoints that the snabbits are traveling towards. One of our biggest challenges, programming-wise, was being able to have opponents to race against. This is very important, and because this gets us beyond from just a sandbox in which we're driving around with to an actual game in which we can win and lose. So how we did the AI cards was extending on the snabbits, but actually applying the same same controls that we have to how we have our players, so we can make it more even. So similar to the snabbits, there are invisible waypoints placed around the track that the AI cars drive towards every time, and it adjusts its turn and its forward based on what's its angle and distance from that next point here. So as long as we have those points, as long as the points are positioned correctly on the map, the AI car should be able to drive all the way through.
Another way we were going to have the player be able to race against other entities was a ghost cart. And unfortunately, this didn't make it into the final game. I was able to get some parts of it working, and some parts of it never really worked. But the way this worked was the player would complete the race course once, and while they were doing it, a script would record the player's position and rotation at a certain sampling rate, and then it would play back those movements the next time the player played the track, so they could play against their past self. And the way this worked was at a certain sampling rate, it would record the position and store it for when the replay is going to happen. And for the times where there wasn't a specific position recorded, like in between two timestamps of the sampling rate, it would use spherical interpolation to estimate where the car would be, to make sure that this would make the replay look smooth, but it would require less storage of numbers while the player was playing it the first time. So this never got in the game, but since we had the AI carts, we already had a method that the player could race against, and I think we had less than a month left when I was working on this, and there were other things that were more important, so I let it go, and we moved on to other things. And then we also had to spend a lot of time on user experience kinds of things with this game, like the visual effects and the sound effects. We wanted this game to be fun to play, and we wanted to make sure there were effects that show the player what's going on. Like when you're flying or when you're drifting, there's sound effects and there's particle effects. And a lot of time was also spent on making sure the controls felt really good to play and make sure they responded well to what the player was doing. And in the end, I think we're pretty happy with how the game plays and how it what cues the player has during the game.
In addition to having to drive around the cart and being able to make it and being able to get ahead of the AI carts, we also have obstacles in place so that if the player hits them, they'll have a delay in which they will stop moving and need to wait a few seconds before they are able to move again, which is an additional challenge in there. Obviously, we went over before with the snabbits that move around the cave area. Note that they do so in herds, and they're actually quite big here, so the player needs to avoid them, move between the gaps in the herds, and yes. So in addition, we also have fire that rains down from the lanterns if any car gets too close. So obviously the player has to avoid the fire. Call this a replacement for the red panda dill because we couldn't quite get to it, but it looks great.
And some other visual effects we had were the drifting sparks that happen when the player hits the shift key, and then airbags that show up on the side of the car when you're in the low gravity zone to help cue the player into what's happening. So for these, the Vivian implemented the particle effect for drifting, and Greg modeled the cart and the airbags, and then the programmers added this into our scripts to make sure that these effects would play at the right time. And then we had sound effects. We wanted to have sound effects at the very beginning. So I didn't know anything about this going into it, so I watched a lot of videos. And in the end, we ended up with a system where you can add a sound effect into any script with just one line of code, which I was really happy with. There were not a lot of like dependencies that you had to add to every script that you wanted a sound effect in. So it made it really easy to add sound effects wherever we wanted.
Okay, so now it's time for our video demo. I'm just going to play through one lap of these and then we can do questions. On the left, you can see the green AI cart, and the blue cart is our cart. And boost. Drifting really helps with tight turns like that.
You can see in the bottom left corner we have a mini map to tell you where the carts are.
When the player hits a snabbit, the cart staggers for a minute.
Second.
Oh yeah, 1 second. A minute would be excessive.
Another thing that we changed kind of at the very end was we made it actually more challenging, because for a while it was incredibly easy to beat the AI carts. But now they're a little smarter, and they actually find the acceleration boosts, and so you actually have to be a little strategic to beat them.
And for turns that are a little more confusing, we included some arrow signs to make it easier for the player to know. So here in the cloud zone, you can see the inflatables have deployed. There's some magical sound effects in the background, and yeah, the gravity's lowered so you can jump quite a far distance. So here's our castle coming up to finish out our first lap. If anyone has questions.
Vivian, does this video show the windscreen at the end?
Yeah, I can skip to the end. Okay, so let's play at the end. There's actually a bit of plot to this demo recording. As you can see, we're kind of the underdog right now. We're in second place. A cart is quite far ahead. But luckily... Oh, sorry.
And we needed to be able to calculate out where we are in relation to all the other carts. So, yeah.
Luckily, the player is smarter than the AI cart, and we were able to take a shorter route to the end.
Yay!
Okay.
Yeah, and we have different screens that show up. The text will change depending on which place you finish in.
Yeah, so Kara created these lovely windscreens. And now, if you would like to check out our game yourself, you can find it at this link, and please leave a comment. We'd love to know what you think. And here are some credits. We downloaded just a couple of textures to help. That's the end of our presentation.
Great. Well, I'll be watching the YouTube chat to see if we have any questions come in. There's a little bit of a delay, so
okay, got it.
We'll give it a few minutes.
While we wait for that, I can just show off our game page. So, click this,
we have one question from Discord. What was your favorite feature to add?
My personal favorite was the AI cart.
Yeah, that's a good feature.
I think
sorry.
Oh, wait, Kara, you go ahead.
Okay, for me, well, you're actually looking at it right now. It's the UI. I don't know a ton about UI, but for some reason I was just really itching to do some user interface stuff, and so it was really fun to like just take this and figure some stuff out and play around with the colors. I really enjoy front end programming, so that was a part that I really enjoyed doing.
Definitely better than our 1.0 UI.
I think for
A little
me,
bit.
I really enjoyed the post processing because I think it just really brought the track together, and I like the transition from daytime to nighttime in the cave, back to dawn in the cloud area. I thought that added a nice touch.
I think when we like actually got the actual cart model started also, because it actually started looking like a kart racing game.
Do you wanna maybe just show the tutorial or something while we're waiting?
Yeah, let's show off the tutorial. So the tutorial, there's this nice sample track that I think Faith created at the very start. The UI was added by Kiara.
Oh, and I
See,
think I see another question.
Yeah, we have a question from Elliot, who's a good friend of mine. What were unexpected technical challenges developing a racing game?
Definitely the clipping through everything. This was why we needed the respawn right when we finished the prototype.
Right, so we found out that there's this recurring issue in Unity that a lot of people have had issues with online, where I think it's a mix between, like, sometimes a cart has to be much smaller than the track, or if the slope is going up too high, like in the cave, we have a bit of an uphill. Sometimes the colliders just don't detect each other very well, so we'd have to, like, stick additional collider boxes underneath the track to map it out better, or decrease the speed of the cart, make the cart smaller than the track, things like that.
I had a lot of trouble making the drifting actually work. Because like with moving forward and turning, it's pretty easy to imagine that, but like what even is drifting? Like there's a lot more physics going on. And once I got that figured out, it was hard to get it just right so that it worked with our track. Because I had it so it would turn really tight at first, and that didn't work because we have a lot of wide turns. So it took a lot of fine tuning.
Oh, and also configuring it to a controller was frustrating but worth it.
Yes.
Cool. All right. Well, thank you very much, Castle Drift. Let's move on to our next game, Dungeon Falling.
Thank you for the questions, by the way.
Yeah, thank you.
Oh, hello. Let me share my screen.
Nice.
Is everyone on my team ready and stuff?
Yes.
Yep.
Yes.
Awesome. Okay. Good to hear. Hopefully everyone can see things, hear that, all that. But hello everyone. Welcome to our presentation about our game, Dungeon Falling. So here's our just kind of our overview, what we're gonna go through. We're gonna go through the introduction, we're gonna introduce ourselves and describe how the game was kind of brought about. We're gonna talk about our development, with concept art, our challenges, all that sort of thing. We're going to show a sample of our gameplay, and then we'll have our question and answer time. So, let's get into it. Just to start, hi, I'm Gabby Khan. I'm a computer science major, and I'm a senior, and I'm a programmer, and I was the original idea designer of the game.
Hello, I'm Kayla Chen. I'm also a comp sci major and a programmer on the game with Gab.
My name is Desmond Oliver. I'm also a programmer. I did a lot of back-end stuff as well as linking that back-end stuff into Unreal. I also do a little bit of music, and I did pretty much half of a song for this project, which hopefully you'll see later.
I'm Leanna Byram. I'm a comp sci animation double major, and I was an animator on this project. Yeah.
My name's Andrew Carleo. I'm an animation major, and I am also the artist of the group.
Hi, I'm Barsad. I'm an animation and graphic design major.
Thanks, guys. You'll be hearing from everyone as we go on, but that's our general introduction. So let's get into what dungeon falling is, right? So this was kind of part of my initial game pitch, but taking inspiration from various other forms of video game media. You've heard of Hades, which is a roguelike game. You've heard of maybe For the King. It's a multiplayer kind of Dungeons and Dragon-esque level progression game where you go through the team. And maybe you've heard of Octopath Traveler, which has a cool like kind of 2D, 3D environment. And maybe you've even heard the term dungeon crawling, but here we are making the game Dungeon Falling. So, here's a general design and idea. Core ideas are multiplayer game. We intend to have 3 players. It's a roguelike, which means you go through level by level. If you take damage, usually you can't heal it that much, and if you die, you gotta restart all the way at the beginning. And we wanted to focus on random room generation to make it more interesting to explore and fight enemies and all that sort of thing. So the general idea and concept was that players find themselves in this maze-like series of dungeons and are being attacked by enemies. They're proceeding through the dungeons to find that it's not ending, even if they die. Audible gasp. But it's also kind of how roguelikes usually are. We really wanted to have a kind of a mystery kind of feeling going on, and also just have fun with your friends, playing a game together where you guys are just going through, killing enemies, that sort of thing. Probably by hearing that, you might think, wow, that's kind of ambitious. We thought that too from the beginning and throughout the entire project. It has multiplayer, map generation, and a ton of artwork sprites based on the way that we formatted our game. And you'll kind of see that and hear from our artists as well in their struggle as we did it. And our framework used was Unreal Engine. We used UE4. This was before UE5 came out when we started. And we used C++ and Unreal Blueprints. So let's get into some concept art. If we'd like to hear from any of our artists talk about the concepts, feel free.
So I'm Leanna. I'm the one who did the initial concept art for the 3 main characters that you see on the screen. And we wanted to have a warrior character, a rogue, and a mage, because those are the 3 classic classes that everyone thinks of when they think of a roguelike fantasy type game. And I also wanted to go with a color theme for each character. So I picked green for the warrior, red for the rogue, and blue for the mage, because those are, standard colors. Everyone, when you have a multiplayer game and the players are color coded, I was kind of going with that theme to build on the multiplayer idea.
Awesome. Thank you, Leanna. Yeah. And I made that small little GIF at the bottom for one of the original concepts. I'm not an artist, but it was kind of like trying to tell the artist, like, okay, well, I think we want a 2D sprite kind of thing with a 3D world. So it was like kind of a little bit of a challenge to figure that out after, but our artist did wonderfully. So let's talk about some other art. Just briefly before we talk about other art, at the very bottom, we do have a few Unreal Marketplace assets, so I did link it. But all the artists, feel free to talk about this as well.
Yeah. So, this is Andrew, and I was tasked with creating the enemies for our game. I didn't want to go with anything too detailed, so that it would, I guess, take the spotlight away from the main characters. So, yeah, I decided to go with a more basic style for creating the enemies.
Hey, my name is Barsad. I helped create the warriors, or not the warriors, sorry. The characters that the players play, as well as some of the enemies. Like Gabby was kind of mentioning, I guess some of the struggles was kind of creating like a sort of 3D aspect to all of our animations, and having to get like every single perspective, front view, back view, side views, was a lot more challenging and time consuming than you would like initially expect.
We were also using hand-drawn 2D animation, which is also very time-consuming, and just trying to figure out the sizes and getting consistent size and style across everyone's art.
Yeah, thank you so much. I think you guys did excellent with it. So, next, we'll talk about some more of our developmental challenges and get into kind of the nitty-gritty of what we went through in this process. So to begin with, our team, none of us had experience with networking. I'll talk about some of those struggles of that in the next slide, but it was pretty daunting to see what it's like to work with networking in any kind of game engine, especially Unreal, which did have a lot of tools for us that made things a lot easier at times. But it definitely was like oh, none of us have really tried this, so I guess we're gonna go for it, huh? Kind of moment. Our next kind of main topic was scope. If anyone wants to kind of briefly mention scope again, go for it.
Well, one of the biggest things I want to mention is that one of the reasons why we chose Unreal over all of our other choices for game engines is because Unreal had essentially built-in networking for most of its objects. The problem is the objects that we needed to use to import 2D assets into a 3D world in Unreal did not have any online support at all whatsoever. So a lot of our time was dedicated to that, despite the fact that that's what we were trying to not do, which ended up being a major setback in our project. But I still think that we did extremely well for the time that we had.
Yeah, thank you, Desmond. Totally agree. And I know Barsat mentioned this earlier, but there were, and so did Leanna, but with the illustrations being hand-drawn and things, I'm sure that was a lot of the scope of getting that done. Going from there, we had also some various issues with replication, which is connected to networking, with sprites, health, and attacks, which a lot of that was what Kayla worked with. If you want to briefly mention anything about that, Kayla?
I mainly worked on the main gameplay with walking around and fighting enemies, and definitely there were a lot of challenges when it came to the sprites. Even now at this stage of the game, we don't have all the sprites in that we ended up making. The concept was to have this sort of 2.5D that they sometimes call it, blend between the 2D assets and 3D world, and definitely because tutorials were always focused so much on 3D animations and things, it felt kind of like working from the ground up, trying to get all the 2D animations and states in. So yeah, it was a lot of different things to consider and a lot of tutorials watched, but for the most part, we have sprites in the game, and that's awesome.
Yeah, thank you, Kayla. I will say tutorials were our MVP. There are so many out there, but they're all very different. So connecting everything, very fun, very time consuming as well. But our last kind of big challenges, which we'll go into a few more technically, but our very general other development challenges we had were testing. It was kind of difficult to test different networking things due to the fact that you had, like, Unreal Engine has a built-in, like, spawn multiple screens and test with that to kind of do multiplayer testing so that you could simulate it on your own. But genuinely trying it with another person was the best way to test our game. And with everyone being very busy college students and all of that, at times it was a little hard to test. And also, personally, I was a beginner in using Unreal, other than some smaller projects. So there were a lot of quirkiness things that we ended up figuring out about Unreal throughout the entire semester, which was kind of fun, but also like, what? Why do you work like that, Unreal? It was like that, basically. I'll just talk about briefly some of my other networking challenges and more specifically Thank you. More specifically, and we'll move on to some other stuff after that. So overall, we ended up using the Unreal Engine Advanced Steam Session plugins, which basically lets you connect to other people's computers using Steam, which is really cool if you're friends on Steam and you have various friends on Steam in different places. You can play a game together if you work with it. That was an interesting thing to work with, especially because there's a lot of like, oh, actually, you need to go into the inner files of all the game itself and edit individual variables and things to make sure that it actually let the plugin work rather than just enabling the plugin, which I thought it would be initially. But we are here now and it did work, so that's a good thing. We had some issues with replication when it came to our 2D animations, which Kayla did briefly talk about in terms of our challenges. So that was a lot of like, why is this not working? Let's try this. Let's try this. So a lot of testing all the time, which was great. Same thing with health. And another thing was just, it was difficult to figure out how we could get a lobby working through Steam, because despite having the plugins and despite having kind of a good setup with Unreal, there were times where things are a little finicky and you had to edit some small things that you maybe didn't think would be a big deal. So that's all. We had a lot of build errors with that as well when it came to networking. But that was like going in the files and like changing little individual things like I talked about earlier. And that's a sample image of our server stuff, but you'll see it when we do our demo videos. We'll next move on to our next part with Desmond.
All right. I just wanted to take a bit of time to explain how I did a lot of the back-end things, specifically the actual random generation that is in the game. If you want to, next slide. So first, I'm gonna just break it down into parts. First, it's like deciding to place rooms, and then after that, I use a bunch of algorithms to determine which rooms are actually going to be connected through hallways, and then I actually use another algorithm to draw the hallways, and then I add all of the extra stuff like where enemies supposed to spawn, where people supposed to spawn, with the exit to the floor, that sort of stuff. So the first step is just placing rooms. I essentially just pretended like it was Tetris, where we randomly place rooms of random size on the field. It's literally just a queue of random rooms. You can see a few of them are just rectangles or squares. Some of them have the corners cut out, but they're like L-shaped. There's some cross-shaped, that sort of thing. Basically, how it worked is if it didn't fit, you'd put that back at the end of the queue, like Tetris when you're holding a piece. And you just kept doing this until there were either too many rooms or you tried to spawn a room and it failed a certain number of times. Next slide. After that, once you have all the rooms that you want, we use this algorithm called Delaunay triangulation. Basically, the idea of this algorithm is that if you are given a set of points, you want to figure out how many connections you can make while making the least amount of connections possible. And what you end up getting are a bunch of triangles, that's basically what triangulation is. So you can see on the right, I actually drew out what the connections would be. It really didn't take that long to implement, nor did it take that long to actually run. It runs in like 25 milliseconds. It's actually ridiculous, regardless of size. Next step is, next slide, is another algorithm called minimum spanning tree. Basically, so you have these rooms, and then you have these points to these rooms, and you establish these connections that you can make with all the possible rooms with least number of connections. So now we use this minimum spanning tree. Minimum spanning tree is basically an algorithm that ensures that all of the points on a graph are interconnected with the least amount of connections. So basically, you take a cost for each point, for each edge on each point. And with that, you go, which one can I choose that will give me the least cost? So the cost here is distance, right? Like you want to be able to get in between each room as fast as possible. So that's pretty much what this algorithm is. I also added a few more connections in just so that it's not like one room only goes to one other room and whatnot, because that's just kind of boring. And then the next step is actually drawing the hallways that connects each room. Now, next slide. And with that algorithm, I used A star. A star is a pathfinding algorithm. If you've ever wondered how a lot of, for example, Google Maps works, they basically use algorithms like this. A star is a very, very efficient pathfinding algorithm that allows you to determine the fastest way to get to 2 points, regardless of the obstacles around it. Essentially, use, like I said, a cost. In this case, the cost is obviously distance, because you have 1 point, you have the other, and you want to basically keep recursively going to the next point that will give you the least distance. One problem: it is a little too efficient. If you see on the graph on the right, you can see that the algorithm will always take the literally the most efficient way. As a result, you see really wonky things, like it will literally just turn a corner as soon as it possibly can. Um, and as a result, if you go to the next slide real quick and then switch back, you can see that the hallways are really, really weird. Like at the top, you have Mr. Squiggly over there, where it's just curving all over the place, and that might look interesting, but actually traversing it is so painful because you have to keep hitting up, right, down, left. Like, it's ridiculous. So if you go back, I actually added another cost based on that, based on the direction of the path, so that the algorithm would only ever turn when it absolutely needed to, and you'll see the result of that later. Other optimizations, basically, this was based on a project I did like 3 years ago, and I found out that the A star algorithm I was using was actually running way more than it should have. And the result of that was basically me not looking in the random library that I used because I didn't want to implement it myself. It essentially, for example, like you see on the right, you can see that the algorithm looks at the wall, goes, "Oh, this must be the closest point," and then it hits a wall, so that it traces back and goes, "Oh, this is where I'm supposed to go." Well, basically, in that algorithm, whenever that happened, it would just scramble all over the entire field. So it would essentially read every last point on the grid for every direction, up, down, left, and right. And what that gets is it literally looks through every square, n times n times n times n times. So if there are 100 squares, it'll look at it a million times, something like that. It was painful. Next slide after, and then again. There we go. And this is what we get after all of that. You see, all of the hallways are straight. All those little symbols on there are, I think they're mostly enemy spawners and like various items or like things that you can that are placeable in the game. I think a few of them are just like trees or something. They're spawners, exits, that sort of thing. There's a lot of diversity. And now, if you get to the next slide, we can see what it actually looks like in game. The end result ended up looking really, really good. I just took the assets that we got off of the Unreal Engine marketplace and smashed them together and found a way to spawn them in Unreal. And this was the result. And it runs extremely smooth. Like, this runs in like under half a second. I think this is a 64 by 64, 32 by 32, I think. Go to the next slide. This is 64 by 64. It can get really huge, and again, all of this runs in under a second. So it's a super fast loading time, and it just works a lot better than I expected. Even more so if you go to the next slide, like it gets ridiculous. I got so bored that I tried to run this algorithm running on 1,000 by 1,000, and it still worked. I have no idea how, but it did. Instead of taking 1 second, it took like a minute, but still, it's pretty impressive. I just felt like that was worth mentioning. I think that is the last of my presenting. But yeah, thank you.
Yeah. Thank you, Desmond. I'm glad we get to go into some depth with that because you did a ton of stuff that's kind of back end that deserves some more appreciation. So now we're here. Let's go into some of our live demo. I have 3 brief videos to kind of display some of the main mechanics and inner workings of our game. So to start with, this is just a sample of multiplayer, how it works. You can create a server. I'm calling the server Hello YouTube, because here we are on YouTube, and you can set the players to 3, and we're using Steam. I spawn in, I picked the mage character earlier, and this is one of our, this is our technically our temp level for when you first load in, like a tutorial level sort of, to just test things out. You see that imp came to try to attack me, and then you see it ran to the left because Kayla joined me with the join server button, and she also picked the mage. So here we are kind of just running around in this kind of 3D but 2D environment. You'll see it more clearly with Desmond's implementation in the next video, but just wanted to show kind of what can happen with 2D, with our networking overall. And if you also notice, it's just that when you get multiple players in the game, it's cool. It's fun to see your friend running around with you while you're being chased, and also the enemies can chase both you and your friend and, attack you and all that. It's not like just one person gets attacked. So let's go to the next one. This is kind of another video of us proceeding through levels, and you should hear some music here in a moment. Hopefully it starts here. Hopefully it's loud enough for everyone on YouTube to hear, but this is Desmond's music. And here's kind of our main menu. And here's me. I'm doing Space War is our game, quote unquote, because that's the Steam dev ID. So whenever you're networking with a dev game, Space War is the ID you can use. Here's our character select. You can pick Rogue, Mage, or Warrior. Ba-bam. Here I picked Mage, and then I made another server. Just because I wanted to kind of demo this again. So I'm calling it Hi Again. Except for I capitalized the G. But now we have level progression, right? I already showed you kind of how the tutorial level works. You can attack things and all that. But there's our hole, because you're falling through the dungeon, right? Kabam. So here we are being attacked by various enemies, running around through the map area. You can see that they're doing damage to us. We're doing damage to them. But we kind of want to find the hole to get to the next part of the level, right? So we're running around, searching for it, looking. We see a lot of mushrooms and rocks, but not a lot of, ways to proceed in the dungeon. They're chasing because they do not want to let up unless you kill them. But I didn't want to feel like fighting them. So I'm zooming, but the hole seems to be missing. So with this, I'm going to end up demoing what it looks like if you die in our game in just a brief moment, which will be kind of easy to see since there's so many enemies trying to kill us. Around here, I think. Yeah, I'm like, man, I can't find the way to the hole. So I'm like, okay, looks like these enemies are just gonna kill me. And this is what happens when you die. When your health hits 0, boom, you are felled. Dungeon felled. Alright, I'm not running with that joke anymore. Anyway, you can retry, pick a new character, restart a new server, all of that. And with our final video, I'll just briefly show, get to out. Yep, our final video, I'll just show what it's like to be the warrior. You can run around as him. The rogue you saw on some other slide, but this is just some warrior gameplay. And you see he fell through the level because he's dungeon falling. Here he is killing an enemy. As we go on, let's see. Oh, right there it is. There's the hole to get to the next part. So you're like, you see it right there? Like, okay, there's the hole. Hit X. Boom. Oh, I did briefly forget to mention that when you're attacking and all of that, WASD is your movement and X is your attack. So whenever you get to a hole, you can hit X to go in it to get to the next level. And whenever you're attacking enemy, you hit X to attack them. And with that, that is the end of our presentation. Thank you for your attention, and I appreciate you guys all coming out to listen to us today.
Okay, first question. What was the hardest and most interesting bug you had to fix on this project?
Oh, well, I'm sure we all have our own favorite and difficult bugs, to be honest. I think personally, I thought one of the most weird ones was when obviously we had a tutorial level initially, and then after we went into a maze generated kind of levels, right? So we had like a little spawn in where you can a lobby to a degree where you can get in with your multiplayer friends and then go to the next level with the hole in the bottom left corner. But for some reason, the enemies, even though they're the same enemies that we spawned in the dungeon world, in the tutorial world, were not chasing you when we put them into the map world. And we spent like a bunch of hours trying to figure out why they weren't chasing us. And it was some sort of hitbox issue with the floor. And it was just kind of surprising to be like, wait, it was just like, and it was like also the nav mesh box, which like lets the characters move and stuff. It was just like, are you serious? Is this really the bug that we had to deal with? But some of our other developers might have some other favorite bugs if Kayla and Desmond have one.
I'd like to share not a difficult bug, not even a bug, but just like something that was funny that we all laughed about. When I first loaded in sprites to the game, like for the first time, the sprite was like really, really large, and there was just a giant warrior that was half in the ground. That was a funny thing.
Yeah, I'm an artist, but I just want to add on to that because this plagued me for the entire semester, and I knew you were gonna talk about this, but the warrior is when I designed the 3 main characters, the warrior was my least favorite, and he was used for like every instance of testing, and a lot of times he was the only character for a really long time. And it all started with like the giant warrior in the very beginning when we put the art in.
Okay, we have a question from YouTube. How did design and game balance change after each play session together?
I will say that we had to kind of tweak the health and how much you can actually get hit and stuff because, well, since it's a roguelike, as you keep going, your health stays consistent, but you are taking damage and your friends are taking damage and all sort of that sort of thing. So trying to, also since this is kind of more of a game jam sort of game over the span of our semester, we're hoping to get that people could play through at least like 3-ish levels or so to get through with their team and keep going. And it was our ultimate goal if we had stretch goals to like add power-ups and various healing items and things like that. But as of right now, the main balance was that you and your friends should hopefully survive for at least a few rooms, be able to attack some enemies. And it's kind of fun when you see your friend getting all ganged up on by all these guys. You're like, all right, get off my friend. And then you can like start attacking them as well. So it's stuff like that, I think, was mostly kind of like the balancing thing to make sure that people still had enough playability to be with their friends and not have their friend like die in the middle of it. And then you're like kind of alone and bored to a degree. So stuff like that.
Okay, we have another question here. Now that you've done multiplayer once, what would you say to your past self?
Don't do it. Just kidding.
Okay, honestly, I would do it again. I just wouldn't do it with 2D objects, like at all. Like it doesn't work and nobody supports it. There's no point.
Yeah, I would definitely agree on that. Like there were a lot of things that were working fine when we import some random 3D model, and then doing it with our own 2D sprites, it just did not work.
Yeah, I mean, I definitely really liked the concept. I think it looks really cool with the 2D sprites in the 3D world. Like, I really like the vibe, but it was not worth it in the end, I would say, to a big degree. I think I would also say that I should stick to a good amount of tutorial series rather than hopping back and forth between documentation and then one tutorial and then one tutorial done by someone completely different. There's a lot of series that do encapsulate a lot of concepts that I could video hop in order. And I feel like if I had that foundation of, oh, these ones kind of make sense, and if I watch their preceding videos, I kind of get the idea of what I can do further, that would have been a lot more helpful than me hopping around. Though, honestly, I did learn a ton, which I'm really glad. So, I mean, as much as we joke, don't do it, I think it was a cool project and it was helpful to my development as a individual in the game industry, TM.
So we have another question from YouTube. How did the difficulty of the game increase? Was that method successful?
Well, the intention on making it more difficult is that as the floors get deeper, they also get larger. So, like, you start out with the 32 by 32 side, and then it eventually grows to like 76 by 76 because that's as far as it can go without taking more than a second. And you'd think, oh, that's just a few parameter changes, but no, it adds a huge amount of land, and the number of enemies that spawn in my algorithm are based on the number of spaces on the entire map. So yeah, it could get very, very hectic.
Yeah, definitely.
Okay. Well, I think that's probably all for our questions. Thank you guys so much. Moving on to Expedition.
Oh man. I'll share my screen here. Can you guys see that okay?
Yep, we can see it.
Yep. Okay. All right. Welcome to Expedition. This is our game for the game development class. My name is Seth Davis. I was the lead designer and programmer on the project.
I'm Kyle Davis, no relation. I'm also a programmer on the project.
My name is Megan Calero. I'm one of the artists on the project, and I also made the music.
I'm Michelle Diesta. I'm also an artist in the project.
Hey everybody, the name's Joseph Kemp. I'm one of the animators and designers on this project.
Okay, so what's this all about? This is Expedition. It's a simple, relaxing adventure game that sets a vibrant world. You spend your time as a wildlife photographer taking pictures of all the wonderful flora and fauna as you explore the many biomes of the old country. And you can learn more about these creatures and flowers that you encounter by filling your encyclopedia using the power of your drone camera. But it's good to keep in mind the battery on your drone camera, as if it runs out, you'll have to return to the hub.
So in developing the game, we took what we like to call a two-fronts approach. Basically, we worked in 2-week sprints. So at the beginning of a sprint, we would all come together as a whole team and decide from a production standpoint what we want to put in the game by the end of that sprint. And sort of divvy out enough work that both the programmers and the artists would be satisfied. And then we would go in completely separate directions and do our own thing, with me and Seth working together and the artists working closely together. And then once all that was done, we would come back together and put it together, and somehow that never came back to bite us, except for maybe some small merge conflicts. But other than that, it worked pretty well. We tried each sprint not to take on too much of a task. We always sort of went by not only the motto measure twice, cut once, but also under promise and over deliver. So we would always end up taking on more than we had originally planned each sprint, because we kind of tried not to take on too much in the beginning. Next slide. So one of the things I worked on personally was the 2 cameras. We wanted the game to sort of have 2 main views when the player is playing. One being the player camera, and one being the drone camera that is used to take pictures and interact with the environment. So the player camera is a lot more zoomed out, and this is to facilitate sort of a better view of your surroundings. We found that originally the camera we had, you would often get lost in the area. Things would start to look kind of samey, and that was also a problem with the map. But once we zoomed out, it was a lot easier to navigate. And then when you're ready to take a picture, you activate the drone camera, which is a little bit more zoomed in, but it's still it simulates playing with a drone camera, basically. So it needed to be fun, immersive, and early on we decided we wanted to have a hub world, and one of the things we did to make sure that was necessary was make the camera battery limited. Currently, we don't make too much use of the concept, not as much as I would like, but definitely we had ideas for future uses of the hub. I also designed the world map. This is a full zoomed out view of the whole thing. We decided pretty early on that we wanted to have a square map. This would allow us to kind of bound it more easily than sort of the earlier stages where we were creating custom shapes and locking them in with a bunch of tree objects and overloading the CPU, and locking it to a square allowed us to put bounds on in a smarter way and sort of save a lot of computing power. The two tenets I really stuck to when designing this map were making it feel full, but not making it feel full for fullness sake. I wanted everything to be placed with intention. I wanted it to feel like each part of the map had its own thing going on, and it was sort of connected with connective tissue of just nice little formations, and maybe a patch of bunnies here and a formation of trees there, so that when you're moving between these larger event objects, there's not just empty space, but it's also not cluttered space.
All right, let's talk game design. So when we started this project, we had three big design pillars mostly, and those were exploration, progression, and dual-purpose design. And I believe we accomplished all three of these pretty well in our final product here. So for exploration in our final build, you're able to explore three unique and interesting biomes. And like Kyle mentioned, the world is large, but it's not too large that it becomes empty or repetitive. There's still a sense of exploration without much monotony. And exploring is also really vital and encouraged through gameplay, because certain animals and plants may only appear in certain biomes. So you really need to explore the map to fill up your encyclopedia. And that leads us into progression, which is sort of the main driving force for the players in our game. At the beginning of the game, you start with an empty encyclopedia, just kind of filled with a bunch of blanks and question marks. And I think that really helps, seeing those blanks and question marks helps drive the players to really fill up their encyclopedia and get a sense of completion for the game. And this sense of completion is visualized through the images and names and descriptions that show up for the animals you take pictures of. And as you collect entries, certain descriptions of plants and animals might clue you in on how to take pictures of certain secret plants and animals that are well hidden within the world. And finally, probably our most important design pillar was our dual-purpose design using the game's camera. So we really want the camera to take advantage of this design philosophy going in. The main way this works is taking a picture not only adds data to your encyclopedia, but it can also cause lots of events to happen in the world as well. You can take a picture of a tree, which might spawn a squirrel out of the tree, or you might be able to take a picture of something to activate some sort of landmark. You're also able to use your camera lens to see the current data you have on certain creatures in the world. So you can just kind of hover over, see what data you have at that point in time, and decide whether you want to take a picture or not. Also, there's a battery too that Kyle mentioned. Battery is an important limiting factor to keeping you engaged in the world and from using the camera too much that we felt like. Now we have the back-end architecture. This was sort of important for our game to make additions of new creatures and plants really easy to add. We took advantage of polymorphism to do this, to distinguish between the different types of encyclopedia entries. So we have sort of a base photo object class that we use to kind of encompass everything you can take a picture of. And from that stems plants and animals, which each hold their own different functions that children can use in order to run code and override functions as well. Like a common override function we used is like a picture taken function, like code you want to run when this creature has their picture taken. What do you want to happen? Should it get scared? Should it spawn something? Should it attack? Whatever. But this sort of implementation of polymorphism made things really, really easy. All you need to do is just create a child of like the base animal class, give it a texture, and boom, you've got yourself a brand new animal. It doesn't do much, but it works. Next, we kind of had our own custom resource that we used to create encyclopedia entries for the game. As that's sort of an example of our main bun encyclopedia entry on the side there. You can give it an image, an animation, a name, description, weight, height, and speed. Pretty much everything you could want for an entry in your encyclopedia. And additional things as well to help with game programming. So this also helps to make the creation of plants and animals really easy by just being able to create a new file and fill it in with details and attach it to an existing or new animal, and it automatically goes into the encyclopedia, and it works pretty well.
So
this,
I'll
go ahead.
So this was the art created from a previous member of our project by the name of Anna. I'm gonna screw up your last name, Anna. Tether.
It's Tether.
Heather, thank you. But she did an excellent job of designing the original assets from the prototype of the game before the project expanded with the inclusion of myself, Megan, and Mesh later on.
Right, and these are my sprites. I tried to keep the art as close to Anna's as possible by keeping it like kind of simplistic. So I was in charge of making the cherry blossom biome. So I have cherry blossom trees animated, and we were Seth was talking about using particle animation in the Godot engine, and in the middle is a little snippet of the theme that I made for the game.
Are you guys able to hear that?
Yeah. Okay. And then the squares you see are some of the tiles for just the ground of the cherry blossom biome, as well as the sprites and the animated sprite of the cherry blossom bunny and the ghost bunny. because it was requested that we had something dead in our game for some reason. And hey, as well as the adventure theme for the overall like part of the game.
Hello, Mesh.
Here's more parts for the game. So for since we're going for like the adventure kind of feel for the game, so we have this kind of the hub space for our character. Now we went for like the camping kind of aesthetic with that. So we have the tents, and we also added some tables and the bikes just for like aesthetic. We also have the hot air balloon for that's the mechanic for exiting the game with through the hub. And we also have the I also took care of the camera elements, like the camera battery and stuff like that, and some of the transition styles, since we have different biomes of the game. So each biome has a very distinct color and design to it. So we try to like blend it in, so it all works well seamlessly. And here are the two different animals that we have in the game. So since we're going for the weirder side or like the fantastical side of the animals, we have the bush lion. Funny thing about this one is I just got an inspiration of this when I was just like staring at a bush and then just thinking how fun it would be if there's like a lion just hiding in there. The ice snail one is kind of an accident one, especially the size, because we planned. It's an accident when I exported this. It was so big, and since we because of that, the team decided it might be fun to have the ice snail bigger than the others. So it's more of a slow giant that we have, and for the player character, we wanted to at least incorporate with something else. So it's not just just going around. So we added a hub transition animation for it. So we have the drones. I have the animation for the drone, and then once you want to go to the hub, an animation plays where it's gonna come into contact with the player character, and then it's just gonna fly away.
Hey everybody, this is Joseph. So I worked on a lot of the tile sets and sprite work and one of the animals for the ice biome. I specifically worked on this little owl friend we see here. I have one entry for his standard movement, and the second animation is for what he looks like in the encyclopedia. The tile set you'll see below is basically it's a collection of tiles, both snow, standard land tiles, transition tiles from ice to rock or snow, and yeah. Next slide, please. Okay, so this is the title screen I designed. The first two were the rough placement that were created at the beginning, and then we have the final animated title screen that will appear in the game on the right. And here we have, I don't know, I'm hoping those worked, and if they didn't, oh yeah, so basically they're just sound effects that I worked on. I also worked on creating the Foley sound effects for the accompanying of the things you do in the game. And on the right, we also have a scrapped environmental sound that didn't make it into the end product, but I thought to include it anyways. I don't know if it's gonna work, but yeah, maybe not.
Oh, can you guys not hear it?
It's just very quiet, so I would just maybe I'd just ignore that.
Okay. All right. So a few lessons learned during the course of the project. One, or probably biggest lesson / challenge, was learning a new game engine. It was a lot of fun, but when we started our project, everyone in the team sort of had experience in totally different game engines, and so we need to kind of settle for one, of course. So that's kind of why we ended up going with the Godot engine, because it makes it really simple for animators, artists, programmers, all sort of to work together on the project and within the same engine. Another good lesson to learn was good source control habits that were great for working in a group setting. Me personally, this is the largest group I've worked on in a game. So we all sort of had our own Git branch that we would push up to, and then at the end of the sprint, we would merge it and hope there wasn't any conflicts. There usually wasn't, which was great. But it's good that we had that in order to fix the small few times we did. Another important skill is to have is adaptability. A lot of people have different ideas on how the game is going to turn out. So we need to be able to adapt these ideas design-wise and make sure everyone's ideas are heard. Even the class's ideas in some scenarios were awesome and definitely went into some decisions we made into the design. And communication also saves both time and effort. At the beginning of each sprint, we'd meet early in class to write what we needed to get done and create a strict sprint plan in order to accomplish your goals without question. And now it's demo time. So I might need to stop streaming and then restream with the game. Okay, I think that's working. Awesome. I'm going to turn the volume down a little bit because it's a little loud on my end. But if you guys can see, this is our game. We're going to do a live demo here. So I hope it goes well. These notoriously always go well, of course. So we have a little tutorial text that kind of describes the game and some controls as well. Basically how to play the game. We also have some credits. But let's get started here, and I'll kind of just show you around the world. So of course it's an open world. You can kind of walk around. You'll see we spawn here next to a few buns. I can toggle on my camera mode and move independently of my camera. Also, team members, if you have any things to add while I'm going through, feel free.
No, you're good. I'm good for right now. Just keep going.
Okay, yeah. So if you find an animal, it'll kind of show you that you don't have any related data, and that's also reflected in your encyclopedia, which is completely blank. It's got nothing in it, but it's really fun to kind of fill that up. So we'll start by taking pictures of Slowly Bun here, and you'll see it fills in all the information on the creature there. So if we go in to our encyclopedia, you'll see that it's there. It's got a weight range, height range, description, and an image. One thing you'll probably notice is that the weight range and height range are the same, but that's because all the animals are actually dynamically sized when they spawn. They kind of randomly change their sprite size and also height and weight. So if we take a picture of a few different ones here, probably good amount. We'll take this guy. Oops. And then you'll see now that we actually have a different height and weight range because we found different creatures at different heights and weights. So we can also kind of go around and take some more pictures. Oop, you'll see that that was one of the interaction things I was talking about with our camera. We took a picture of this tree, and we scared a squirrel. So, sorry, buddy. I'm going to take a picture of you, too, because we got to log everything. So, boom, now we got a tree in here. We also have a squirrel in here. Now, there are a variety of little secret animals hidden around here, but I think I would like to showcase one that I think the whole team really enjoys. And that is our ice snail. I saw people raving about it in the Discord chat already. But in order to summon the ice snail, you'll see that we have a little shell here, but it's kind of hidden. It's not really useful to our explorer needs. So in order to kind of break it out of its shell, I'm going to... Oh, he hit it all. But the idea here is that you want to scare the blue bunnies. I'll take a picture of it real quick. Oh, that was the tree. But if we go over to the blue bunnies encyclopedia entry, you'll see that it says it's a breed of bunbun. It's easily frightened, said to enjoy the company of cold, slow creatures. They won't scare like that. That won't scare them. And they like to congregate in threes. So how about we congregate the blue bunnies here right next to our ice snail, and let's see what happens. Now we've been given a proper hint by the encyclopedia. There's also tons of owls here, and you'll see they're sort of hidden before they get scared. See if I can find the final blue bunny. There he is. There. He's scared, so we're gonna kind of scare him where he'll be happy for the time being. And look, there he goes. There's our ice snail. So you can finally take a picture of him, and he's in our encyclopedia. So he's just a cute little guy, or big guy, really. But yeah, there's a biome I haven't even showed you yet. There's a guy here. Hello. Some people are very excited about the ice snail. But I would be happy to take some questions now at this point in time, unless there were some things that team members wanted to add.
Why don't you show a little bit of the grass, or what would I...
the bamboo forest?
Yeah, bamboo forest.
I want to keep some of the stuff secret. I don't want to like activate too many things. But hey, this is our bamboo forest. We're using particle effects for the trees, which I think turned out very well. Oh, there's a little guy over there. We also have our pink bunnies, which are very adorable. They also have the particle effects. I think all the biomes turned out very well.
I'm seeing a lot of love for the ice snail.
Yeah, I didn't know so many people love the ice snail.
I'm reading the comments on the YouTube live stream, and everyone's raving about the snails too.
Really?
Time to change the mascot.
Oh, our mascot is already the bunny. Oh,
nope, bunnies are out.
Bunny's out.
Yeah,
ice snail.
luckily, Sadly, I don't think the snail's going to be as quickly to animate as the bunny.
You'll have to figure that out yourself. How to find the ghost bunny. I'm not going to reveal all the secrets to you guys. You know.
So first question: how do we see the ghost bunny? Oh wait, you saw
that just answered that.
Yeah, sorry about that. All right, here's another question. What's the most useful piece of feedback you got when playtesting this game?
Ooh, that's a good question.
Probably that the map was too big.
Oh, that is, yeah. You know what? That is it. That's definitely it.
The game was kind of unplayable at the end of the previous sprint because we kind of went way overboard with the map. So, tightening it up allowed us to really let the assets that we had shine.
Yeah, it was very big, and there was a lot of emptiness, so I'm glad we reduced the size to something more breathable.
We have a question about, can any part of the terrain harm you? And I guess not necessarily, but I guess...
Not necessarily. I'll let you figure... Well, I'll show it off. Because it's kind of a fun thing. I like it. We have the bush line, which stays a little hidden, but if you get too close, he will get a little aggressive. He'll push you away. He's very territorial. So he's not necessarily going to damage you, but he is a little territorial. Doesn't like you hanging out near him.
There's another question saying, what motivated you to make a relaxing game like this? Like, was there inspiration?
Ooh, well, I think the biggest inspiration was Pokemon Snap. I think that came around the same time that we started making these games, and started pitching them. And I was definitely inspired by that, and I wanted it to be less on rails and more like take it at your own pace. Like, if you see something over there, you don't necessarily take a picture now before it disappears. No, it won't disappear. You got your time. You can explore at your own pace.
Another question from YouTube. What challenges does the player have to solve when playing the game?
So some of the challenges sort of come from your observing of the creatures. I already sort of mentioned observing the encyclopedia entries and really solving sort of riddles that way. But there's also, as you kind of saw with the ice owls, I think they're all flying around now. But they're very quick. If you want a picture, he just flew away real quick, If you want a picture, you need to sneak up on them before they reveal themselves. And it is possible to find them and see them before they sort of fully become fully opaque. So you can kind of sneak up on them that way. There's also another certain creature that I think the class knows about that moves very slow and might be very hard to observe if you don't have a good eye. So that's sort of where the challenge for the game comes from.
All right, we have another question here. What feature did you cut that you wish you hadn't?
Oh, that is a good question. I'm sure I think we should give an opportunity for everyone in the team to answer this, because I think everyone has their ideas.
Yeah, I don't think we necessarily cut anything more than we didn't get around to including all of the things we wanted to do, which I guess is cutting in a way. But I wish we could have made the hub a little bit more useful, because I do like the hub a lot. We should also probably show the transition animation.
Yeah. Oh, yeah. But it's so fun. This is our transition animation.
It is kind of vestigial to the current form of the game.
Right. I'll show it off. Thank you for reminding me. This animation was done by Mesh, and we have sort of the drone fly in. He picks it up and rises up to the top. And this is our hub, where you can return the world. You can open your encyclopedia here. There's just a little tent and a place to quit the game.
So another question, how do you win?
How do you win? Well, I guess there's not technically a win screen, but the idea is that you fill up your encyclopedia. I don't know exactly how many animals are in here, but I mean, I would consider it winning if you found all of them and completed your encyclopedia.
Yeah, the victory is the friends we made along the way.
Right.
I will acknowledge that one of the comments we did get during one of the many sprints from one of our colleagues in class was that like we would finish the book and then like burn it or something like we've known too much.
Yeah. Looks like we got a question in the Discord chat. Personal favorite animal?
Oh man. I gotta think. It's probably
a snail.
The ice snail.
No,
there he goes.
I'm an OG bun guy.
I think I'm agreeing with you, Kyle. I like the bun. I became too attached to him in the original pitch. He was sort of our first animal.
Ice snail's a close second.
That is true.
I would say my personal favorite is probably Mesh's design of the like mushroom, like
the mushroom guy. Let me go over and find him. He was over here, right?
This guy is very difficult to find.
Yeah, he hides under the ground, so you kind of have to be very observant.
What did we name it?
I think it's
There he
the
is.
drill mushroom, right?
Drill
Oh
mushroom.
no, he disappeared. Okay. He was there for a second. I think it's just called the drill mushroom.
Okay.
People love the bunnies.
Any other
Seeing
questions?
lots of love for the game in both the Discord and the YouTube chat, and that's great.
Well, thank you guys.
Thank you so much.
We have, I think, kind of a question from Katie Hirsch about like what is kind of the process for recharging the camera.
Oh, right. So the
Right.
process of you want to go over it, Kyle?
Yeah, I was just gonna say it's currently the only thing you have to do is return to the hub. It was kind of placed there initially to be a reason to return to the hub, but again, a lot of the plans we had for the hub ended up not making it into the final game. So, yeah.
Yeah, you'll see it's going down, and then once we return to the hub and return back, it's charged up.
Vivian asks, sacrifice a bun to a tree for Ghost Bunny. Circle of life.
No.
That's a good idea. Yeah.
It may have something to do with these certain artifacts placed around that may or may not be skulls.
Yeah, we did have a question in YouTube regarding like how do you find rare animals? Maybe you just got to figure that out yourself.
Yeah, I'm not going to tell you
Take
all
a
the
lot of
answers.
pictures.
Make
Well,
a Reddit investigators page. Like, how do you find the rare animal?
The tip.
3 seconds.
Right. The tips I'll give is just be observant of the environment. Read the encyclopedia, and you'll eventually find them all.
Yes.
Great. All right. Well, thank you so much, Team Expedition. Let's move on to the
Thank
next
you.
game.
Thank you.
We have
Thank you all.
Project Kindle up next.
Hello, can you guys hear me?
I can hear you.
All right, cool. Isaiah is going to share his screen and I will be presenting, so give us a second.
Are we good?
Yep, we're good.
Yep. All right. So, welcome everyone. This is Project Kindle. Well, you'll hear from each of the team members a little bit later. My name's Camille, and I'm going to take you through the first part of this presentation. And let's just get started. There's the link that we'll have again at the end to play the game too, by the way. It's on itch. So, our team is composed of 2 computer science majors, 3 art majors. We have Isaiah, the project lead, who played multiple roles on the development. David, the Unity expert, and he did some visual programming. Tahir, who is really good at cartoon style-y kind of design, so he helped with enemy and character design. Aiden, who did environment and sound art, so gathered some Foley. And myself, Camille, I joined the team a little bit later, and I did some environment work. So this project was developed as the capstone for the game development course, and it was done over the course of the semester. Next slide. So, design. What is Project Kindle? So, it's a 2D platformer, a shooter with a classic kind of game objective feel. It merges together action, exploration, and taking inspiration from Cave Story, an indie Metroidvania game. Like, it has a robot too, so we kind of stole from that. And Banjo-Kazooie, an objective-based 3D platformer you probably know and love. On the right, there are some sketches done by Isaiah for the original pitch. So everyone pitches a game, and Isaiah was the one who thought of it, so he had a lot to do with the design as well as programming. So the girl with the pistol, that's Kindle. She's a robot scientist in the junkyard for whatever reason. And there's creatures called the Onyx that you can see there also in the sketches that she's shooting at. And they're monsters who want to do nothing but just cause chaos, trouble, negativity. For this project, we settled on the Unity engine, and David already had experience with Unity, so we felt like we could kind of use it since it was 2D, and that's easier than Unreal. And we felt it would make it easy for all our members to get their work into the game with little hassle, because animation majors have a class where we do Unity stuff. So, as for gameplay, what do? The player takes control of Kindle, and you're trying to defeat the Onyx, those little enemies that I talked about earlier. They've corrupted the junkyard with their presence. It's just a chill place to vibe, and look at them. They're all running amok. You can see that weapon being deployed on an effigy there. So, when they're defeated, they drop a weapon, energy, or heart, so you can kind of collect something after you kill them, like objective-based gaming. And the weapons start at level 1. They can be upgraded to levels 2 and 3, with each step increasing their power. However, if Kindle takes damage, the weapon energy also takes a hit, so there's kind of like, you want to avoid, so you can get not like lessen your power. And if the enemies respawn, Kindle's far enough, there's never like a shortage of energy, so you can keep on going. As for objectives, there are 3 main objectives. 1, to destroy all 5 of the effigies that you'll see later. They look like Kindle with a funny face. And you can find and collect all 3 of the health packs. 1 is hidden in the trash somewhere, so you kind of gotta dig. Junkyard theme, explore, it's fun. And you're also trying to obtain the meteor weapon. You have to use a specific weapon to find it, so go in there and figure it out, little mystery. These objectives can also be completed in any order, so you can just kind of roam around and figure out how to get the game started, how it works for you, and until you get it, doesn't matter what order, and you get a reward as you complete each of the objectives. So, once again, objective-based gameplay. As for the visuals, it's a pretty simple art style for both the characters and the background. Each character sticks to a limited color palette, and we did have like a lot of back and forth figuring out how to stick to that color palette for Kindle and kind of just changing the background and enemies around her so she doesn't get lost because she's the main character. The Onyx use a collective of dark colors, that purple, pink, and each character, like, they stick to something limited for their sprite. The enemies were designed with a junkyard theme in mind. Our other choice was a flower forest, but that would have had to use a lot more green, and I don't know, I guess we just wanted to spice it up. She's a robot, it makes sense. Among the software that we used, A-Sprite becomes very popular. 2 of our artists bought it after seeing Isaiah use it. I'm one of those artists. Fire Alpaca is also another good one that we used. It's a free alternative, and we're just going to go through a quick run-through next of some of the art made for the game. Here you can see more Kindle. She has a little scooter there, hover scooter. We were thinking of a bunch of different concepts with like hover scooters and teleporters, so that was just something there. That was her first stage before we simplified her. And next we have Koro, who's the mastermind behind the Onyx. Note the color scheme that matches. He's not in the game itself, but he does exist in the lore, and we'll kind of get to that later about how we didn't really go into getting a boss final like you typically would for a game like this. These are some enemies done by Tahir. Junkyard theme, we got Mac in the box, Maribot, Rada, Bampo Bat, and Icebox, that fridge dude at the bottom. Due to time, not all of them made it in, but the designs are well done though, so we just wanted to show it off, and the color design as well, done by Tahir. And there's also this underground area, and we found background, you can find, let me re-speak. In the underground element area, you can find background elements made by me and Aiden. That junk pile, lovely, lovely, is me. And then where you see that fridge, car, that's all Aiden. I did the pallets as well, but the pallets, you see how they look kind of 2D. When I first did them, they're a little bit 3D, so that was one of the challenges we'll get into later, of trying to make the game, like, not two-dimensional because it's 2D. And I also animated the title screen, but you'll see that later. And now we are going to show a little gameplay demo and then just go into more everyone's experience with making the game.
Thank you, Camille. Give me a moment while I set this up real quick. So, hold on. Okay. Share screen. Go live. Okay, I'm gonna be messing around with the sound, so Everybody let me know if you can hear it. Oh. Is that a comfortable volume, or should I raise it?
Maybe a little louder.
A little louder, okay. How's that?
We can hear it, but it's still a bit quiet.
So if I, alright, I'll raise it up by. That should be good. Now it should be even. Did it change at all?
I don't know how much it's changed. Let's just.
Shoot. Okay. Hold on. Alright. Right. So this is the title screen made by Camille, as mentioned before. We have an options menu here, so you can control the music volume. It's a little buggy at the moment, so I can't really change it without things messing up in the game. We have credits, which is also a little buggy, but there's my name here. There's David, Tahir, Aiden, Camille, and then sound, Aiden, and me. Right, and let's get into the game. Oh, I gotta adjust my volume on my end real quick. You can still hear the game? Still hear me pretty well?
Yes. Yeah, I can hear you fine.
Alrighty, so we have a welcome player. Mission is to find all 5 FGs on the map and destroy them. With left and right, the arrow keys. This is just the controls. We intended to have a more interactive control section, but we didn't have the time for it, so we'd have to settle for this. Jump with Z and shoot with X. Press A and S to switch weapons. Use C to view goals, weapons, and enemy info. Collect energy to level up your weapon. Find health packs, increase your max health. When a exclamation mark appears above Kindle's head, press down to interact. And have fun. So you can move left and right, aim up, shoot with Z, shoot down, and switch weapons. So I'll just do a quick run through and explain everything that's here. Actually first let me run through the enemies. So we have, these are the sprites for the actual enemies in game. So we have the crawler, the eye drop, the dome, the rata, and the stork. The Marabot, but we got to change the name. And we have the goals listed before: destroy the effigies, collect the health upgrades, and obtain a meteor weapon. Right, so I'll run around and explain. So these background elements here, like the crane and whatnot, these were made by Aiden, excuse me. See if you can shoot things, a little bit of feedback there, collect the weapon energy. Okay. Hold on, I gotta be good at the game too. There we go. So we have the first health back over here. When you find one, you can press down, and it'll show a text box and what happens there. Dome enemy, which David actually programmed, not me. I programmed most of the enemies in the gameplay, but yeah. All the visual stuff is all thanks to David. He worked with the camera and getting all the animations to work for Kindle and whatnot. It's a Marabot. He'll drop things on you if you get too close to him. With a little bit of delay, so you can run away if you need to. Yeah, let me bait him out real quick. There we go. Outred, alright. He doesn't drop anything, so it's kind of just a novelty thing, but yeah. Yeah. So as mentioned before, as you level up your weapons, your stuff does more damage. So now this is doing 4 damage per hit instead of 1. Grab more energy. One little note about the dragon is that you can shoot through walls with it. Grab this other health pack. Increase by 5. Make sure I'm not missing anything while he's doing this. Enemies will respawn, so if we go back to the left, which I will after I cycle all the way around, you'll see that the crawler and the eye drops will respawn over there. This guy here. Show some of their attacks. Or this one. So I believe we're up to 4 effigies right now. So here's the underground area that was mentioned before. A little rata enemy. We have a little sound effect when you get hit by him. I don't know if you can hear that, but it's a little cartoon clonk effect. He'll actually jump up to chase you around. There we go. So here's what we were mentioning before about the hidden weapon. So if you shoot with the vector, you see nothing happens, but if you use the dragon breath, it'll light up. And we get this little thing here. Press down on that, and look at that, we got the meteor. And we can shoot rocks now. Explosive rocks. So they'll blow up. And once you unlock a weapon, I probably didn't detail this too much before, it'll show up here on the screen. So before, the meteor was locked on the bottom, and now it appeared. We're still missing one weapon though, so we'll get that in a moment actually. Just blow this heal up real quick. So that was the last effigy. We get a congratulations, a winner is you, old reference. I'm not sure if anyone's gonna get that. But now we have the Tempest. She's cutting whirlpools. So we have a cheat code, non-cheat code that we have to level up your weapons. So this is the meteor at level 2, or level 1 rather. See if enemies respawned up here. If I hit E, it'll level me up real quick, just as a debug tool. See, we have bigger meteorite balls, and get to level 3, we have very big stuff. The bouncing is a little hard to control, but the damage is very nice. Yeah. And for the Tempest, shoots little bubbles out. Does nice rapid damage. Low damage, but you know, it's quick. Level 2 shoots little discs. And level 3, level up real quick. Shoot very fast, little whirlpool things. So as you saw, the rat down there respawned. And if we dig around the trash a little bit, hit up this little corner, what's here? We found a health pack in the trash, like Earthbound style. Get our last health upgrade, found all the health packs, and we get even more health, because why not? And I believe that is it that we have. Did I miss anything, anybody? Team members? I don't think I did.
That's it.
Yep.
Yeah, I think you got everything.
Yeah, you can see the Tempest here now with its description. Each weapon will show how much energy you have here too. And yep, we got all the goals done. Yeah. So we'll switch back to the presentation. Let me exit out of this. There we go. Let me get this back up. Here, let me do it this way. Slideshow. Make sure I can see this. Live. All right, can everybody hear me? And everybody see this?
Yep, we can see it.
Okay, so as for challenges, we figured it'd be better to show the game off first and then describe some of the stuff we learned. So sorry if it's a little like unorthodox compared to other presentations. So challenges, time was definitely a big factor on what we should focus on for each sprint. There wasn't a lot of time for feedback really on each sprint. So like a lot of the work that was done, we'd have to put it in and then immediately move on to the next thing. The original plan was to have a boss at the end for the player. Like the player would get all these upgrades and you know, build themselves up and get decked out, and then fight the boss with all the stuff they acquired. Or they could fight the boss like, you know, without any stuff and challenge themselves. Eventually, we had to cut that just due to time and yeah. Let's see. Excuse me. Player controls. So when we first uploaded the game on itch.io, we got a lot of feedback on the camera and the player. So the player felt a little too floaty, and some of the jumping was a little off. And so we went back in and fixed that. It was very good that we put our stuff on itch.io first, because when you're working on something for so long, it's very easy to tunnel vision on, like, you know, getting used to how the game works because you're working with it for so long. So outside perspective is very helpful in terms of that. And tackling problems in Unity. So using Unity's biggest strength is its visual approach to game development. It's like super visual. Like the scripting is like fantastic. You can even customize how you want the editor to work in some cases. However, it does encourage a very top-down approach into game development, and it works for. There's benefits to that, and there's also benefits to a bottom-up approach. I am a bottom-up developer. David is more of a top-down developer, and it came to a head a few times, but we figured out a nice little mix to make sure the stuff in the project still gets done. Sometimes I would switch to the top-down approach. Sometimes David would work from the bottom-up approach. And yeah, it's a very eye-opening thing. So I think each the team members here will explain what they learned. Start with Camille.
Yes, so I came into the game a little bit late because we had different original teams, so I spent some time trying to like pick up a sprite to learn pixel art. It's very cool. Love the software, but it's a little like for animation and stuff. It does it in terms of milliseconds, I think. So it was different than what I'm used to. And then also like GitHub, like I had an internship where I used it and they had to like spoon feed me every day. But now I feel like I understand GitHub, so that was kind of a part of it for me. Also, the perspective of the game, because just like making sure the volume of it something doesn't like just break the perspective of everything else, like the palettes I mentioned. Isaiah had to go back and touch it up a bit before implementing the final sprite because it looked like a three-dimensional random thing in pixel art in the background instead of something that is a part of world building and it's not supposed to take you out. Also, standardizing file names, exporting image sequences for the title screen. I think the one that I finally didn't make it in because I couldn't find my folder file because I named it something like title screen alpha background something with a bunch of slashes. So, you know, standardizing names, working with a group, I've learned some things about just like organization makes it easier for everyone and everything. But that's it from me. Aiden.
Yeah, working with standardized nomenclature is very helpful. In my case, I was working between two different between Photoshop and Fire Alpaca, and in between the semester, I did switch over. So it was important for me to have consistent naming functions to keep everything working, along with working between a computer at home and a laptop. So that was a challenge for me to get over. And I also learned to provide many options, both in terms of assets and especially for Foley. So I had multiple different hit sounds that I sourced and mixed that Isaiah could pull from when working.
Hello? Can anybody hear me?
Yeah, we hear you.
We can hear you.
So, I jumped into this project completely blind. I didn't know about any of this stuff, like Unity and GitHub and everything. So, it took some time to get used to, get familiar with the stuff. I started working off of Adobe Photoshop for the most part after I understood like how we were supposed to design sprites. This is my first time designing sprites, so there's that. I was kind of hesitant to use a sprite. I switched over later throughout the semester, later in the semester, and found it was surprisingly easier than Photoshop for the most part because it's already done for you. The sprite is kind of like format is already there rather than doing it manually on Photoshop. So, I mean, it was a nice change of pace whole semester. Yeah, that was cool.
Hello, all. So, of course, I'm David, and working on this project let me learn Unity a lot more, and just made me realize that even though Unity has its drawbacks, it's still an amazing engine to work with. I love working with Unity. I already had experience with it before this project, but working on this project with it made it's only further cemented how like good this engine is for my type of coding, as it has stated. Um, so yeah, learning Unity was a very nice thing. I also learned of course, the general game dev flow and learned how to work in a team and make compromises and keep a cool head no matter what happens. With me and Isaiah sort of coming from different backgrounds, there were some situations where we had to figure out how to make a team implementation on some things. Like for example, we had different ideas how to implement a movement system, but it was very nice and interesting to how we made compromises and found a way to work together as a team and avoid butting heads on stuff and to overall just make decisions that would be better for the game. And also learning how to use Git on group projects and to resolve more conflicts. This project has taught me that Unity with Git sucks a lot if you don't set it up properly. Unity does have this built-in tool called Smart Merge or YAML Merge, which is used to fix scene merges, which is the biggest thing about working with Unity with the version control. It's the actual scene. Git doesn't like messing with it a lot. And there is a way you can set it up, but I only learned how to set it up like a week before today. So it's Unity and Git can work together. You just have to properly set it up first at the beginning of the project before you do anything. But overall, this is a very nice experience. I liked working on this project, and I think it turned out pretty good.
All right, thank you. And as for me, definitely gained a better understanding of the Unity workflow, its advantages and its shortcomings. Actually, my most familiar program is Game Maker Studio, so I did want to try out Unity just because it's a different engine than compared to what I've been using for like the past few years. I do see how it would be useful for like game jam stuff because it's very easy to put stuff into a game and see stuff work. But would I use it for a bigger project? That's something I got to mess around with a little more. Gain insight into different types of development and artistic approaches. So, like me and David mentioned several times, the top-down versus the bottom-up approach. There are benefits and there are disadvantages to each. Definitely got to pick where you want to, where it's appropriate to implement which approach. Learn some valuable lessons on what it takes to lead a team effectively. I made sure to explain all the choices I made as much as I could. I made sure that everybody was working. I made sure to keep the work fun. Tried to find everyone's strengths and have them work on tasks that serve those strengths and help them build that. And lastly, made aware of my perfectionism and how to control it. I had to hold myself back a lot because I recognized, like at the very start, I've mentioned this to my teammates a lot. This class isn't about making a masterpiece. It's about building team development skills. I'm used to working on independent projects where I have complete control over stuff. And I made an effort to have my project picked so that I can get leadership experience and see what it's like to lead a team. I definitely learned a lot of things. Honestly, like I would do this class the rest of my life. Like it's a lot of fun. I do want to see like the different ideas of what people will come up with. I'd like to be like a leader again, or like just a normal member. It seems like very fun. But yeah. In closing, so we didn't. Of course, we didn't. We had to cut out some stuff for the game, but the heart of the game is there. We set out to make a fun game with objectives to complete, and at the end, we have a fun game with objectives to complete. So with that, it was time well spent. Thank you to my group members for everything, all their effort. And thank you all for your time. Do we have any questions or comments? I can't see the Discord chat, so y'all gonna have to help me out.
Yeah, MN Chino asked, does the game run on a Kindle?
A Kindle, nice one. We have not checked that. We can get back to you on that. Are we able to post a link in general? Somebody asked that. I see that.
This art was made by Tahir, by the way. He did a really good job on it.
Yes, Tahir made this. Very nice.
Yeah, it took a few hours.
Yeah.
It's
came out really well.
Thank you. It's hard to draw humans. I don't know. I'm used to drawing monsters, so I mean, she's not a human; she's a robot. But you get it.
I got you. Is that all for questions?
We have a question here. How did your team handle enemy AI?
Enemy AI. So the basic approach was we would Tahir would come up with like just very simple behavior patterns, and I think all of them, like all the enemies work on just a basic state machine. So they'll have a sleeping state where they don't do anything until Kindle gets close. Then they'll have like a chase state or like an awakened state, where they'll actually chase Kindle or like just move around it all. And based on different like collision or like player checks, they would make an action. So like if the right enemy is very close to Kindle, it'll enter its attack state. And then once that attack state is played out, it would turn to its chase state and so on. Same thing for the eye drop. When Kindle's below, it'll shoot its laser, and then there's a cooldown period so that it doesn't like spam lasers, because that'll get annoying very fast. The lasers are very powerful. But yeah, they all work on state machines essentially.
All right, next question. Did you have the lore planned out from the start, or did the story write itself throughout the process?
So Kindle is actually from like I have a the original theme was a dream world kind of thing. So Koro, let's see if I can pull it up. Koro actually comes from the real world. He fell asleep and then he woke up in the dream world and then immediately started causing trouble. So a lot of that was planned beforehand. Kindle is actually a character from another one of my projects that never got to see the light. So I figured I may as well just pull that from there and use it in this because I really like her design, like especially the pants. The pants are really cool. Or just start pants anyway. But yeah, a lot of the lore stuff was planned out ahead of time. The junkyard theme we came up with during development because that wasn't really established until like sprint two out of like four. But yeah, I hope that answered your question.
Someone on YouTube asks, how was it for the artists to work with each other?
Do you all want to elaborate on that, or?
Well, for me, I mean, I was kind of in my own little world as far as enemy designs, so I guess there really wasn't too much conflict with me. I can't speak for the others though.
Since Aiden and I both did environment art, it was more back and forth between the two of us, and also being like, Isaiah, does this look okay-ish? Mostly because of the color things we were talking about. So there was just a lot of like, try this, this works, okay, you did that, good job. So like, I think once we got into like the groove of things, there was also like a Google Doc I made where whenever we were brainstorming, I took notes and just dropped a bunch of photos from Google, like kind of like our own Pinterest board. So I think that kind of helps to be able to go back and not have to like remember everything and be like, okay, yeah, and then I can just message them on Discord. So since we just kind of went with the flow, it was pretty easygoing. I hope Aiden will say the same.
Yeah, definitely. We kind of shared a color palette to work from, and one of the important things Isaiah stressed for the background assets was a reduction in the number of colors used in a single asset, so that really helped.
Yeah, it helps from a organization standpoint. So like if we want to change colors later, we don't have to go back and I mean we can do like effects and stuff like that, but you'll lose some of the charm or some of the detail that was there originally than if we just have a limited palette and then adjust these colors individually. I did want to add to what Tahir said, and I guess for all the artists, really, everybody. I did like provide a lot of feedback. I hope I wasn't like too much. I apologize if I was. I did like try to keep consistent feedback and say wherever stuff looked a little off and try to make it so that the game looked as polished as possible. I mean, that wasn't like shouldn't have been the focus, but I think the game came out well because of it.
Got a question from YouTube. Do you have an example of integrating team feedback into Kindle's art or gameplay?
Art or gameplay, team feedback. Art.
Something I randomly remember, I think, is the Maribot colors got tweaked, like after it was designed, just to. I think that was something that happened. But when we had our midway Arcata presentation.
Yeah. When I was making the sprites for Maribot, I found a dark color scheme, which it didn't. I don't think it went in. I think I changed the colors a little bit. But yeah, in messing with the colors, I did find some like cool stuff to go in. I think Ratas, I made the yellows more bright, and the pink I think a little more intense. In terms of gameplay, team feedback in the gameplay. I know me and David, we were talking about he mentioned before about the original collision system. Eventually, we settled on a more simple like retro style thing where it's just like a basic like short like cache check instead of using Unity's built-in rigid body systems. That and then we discussed with each other about the Kindle's attributes like gravity and stuff like that, gravity and speed.
Yeah, I remember when we were originally trying to implement the movement. We both had different ideas. I wanted to use Unity's, of course, built-in widget body system. Isaiah wanted to go with the more what we called manual approach. And essentially, what we did was we both wrote our own movement systems, and then basically played with both of them, and then we eventually ultimately agreed to just go with Isaiah's implementation because it more so fit what we wanted out of the game. I was a little salty about it, but and working in team projects, you have to learn to swallow your pride and do what's best for the project, rather than oh, I want to implement everything and all that.
Okay, thank you so much, Project Kindle. Let's move on to our next and final game, Set in Stone.
Oh, how do I do this?
Oh, can everyone hear me?
We can hear you.
Awesome. Well, let's get to it. This is Set in Stone. My name is Pierce Jackson. I'm the project lead and lead programmer. The other programmer on our team is Ben Tiemann. Aki Briganti is our lead artist, and Anna Tether is our other artist. In Stone, you play as Rom, a demon, as he attempts to escape the human's castle fortress. You use his ability to turn any door he finds into a passage backwards in time, letting you time travel. You have to solve puzzles and stay hidden because this game is a puzzle stealth game. You have to take actions that will help your future self while avoiding your past self. Our game is a 3D first-person puzzle stealth game meant to be played on a computer with a keyboard and mouse.
So our philosophy of time travel is based off of Larry Niven's law of conservation of history, which states that any actions taken by a time traveler were part of history all along, and that it's impossible for the time traveler to change history in any way. In other words, there's no way for any grandfather paradoxes or similar things to occur. You cannot change the past. So the timeline is immutable, or in other words, set in stone. And there are also but multiple versions of the player will exist at certain time points. When player A goes through a time door, they become player B. Your A's experiences happen around player B, and they have to work around them. So everything that you see is recorded history. So altering anything involving that in accordance with the law of conservation of histories will cause a paradox, which is a game over. So you either have to restart or reverse time. So for examples of what can cause paradoxes, you can't see your past self cannot look at you. Objects must be in their proper place for your past self to work in them. Though thankfully anything out of sight is free game. Also, if it wasn't clear at first, the player can also reverse time, but not in a go back in time sort of way, more like a rewind button sort of function. Aspects of gameplay involve gates, which require a variety of triggers, such as pressure plates, which can be stood on, and pedestals, which require key cubes to be placed on them. Other gimmicks include ladders that can be pushed around, and guards who you must also know whose gaze you must avoid, including, aside from the aforementioned time travel. The development of the game started off in February with the initial pitch. Then there was a prototype. Then came along Sprint 1, where the level access, time reversal, memory objects, ROM's design, and a new time body class was added. And this is where me and Anna were added to the team. Sprint 2 involved pressure plates as well as animated gates. Sprint 3 had the tutorial level major bug fixes, a new camera that used raycasting instead, and optimized lighting. Finally, up next was Sprint 4, which had pushable ladders, which I personally worked on, and the aforementioned guard. The final sprint had added on various levels and some finishing touches, alongside with the title screen and UI.
All right, so replay system in games lets a player record gameplay sequence and then replay it. It's common in video games like the kill cam in Call of Duty, or when you beat a level in Super Meat Boy, it was like all of your attempts through the level. Our game utilizes such a system to simulate time travel. It records what the player has seen, and then when you time travel, it plays it back while the player continues to traverse the level. Replay systems typically either record the inputs or a player makes, or it records the state of the game frame and then repositions things. The main advantage of an input replay system is it has a very low memory cost. It requires that your game engine be deterministic. State-based replay they're more precise and they're more customizable, but they cost a lot more memory. Our game uses a state-based replay because Unity, the game engine we use, its physics engine is not deterministic. And we also really needed the customizability and the precision. We wanted everything to line up and be very precise. Any object that changes over time has a time body class and a time data class, which uses inheritance. They all have a base class, and then each unique object has its own variation. All of the objects then are moved in accordance with the time data, except for the player, which creates a copy of the player that retraces your past actions. One of the major challenges we ended up facing near the end of Sprint 3 was the cameras we were using. We were using Unity's cameras to keep track of what the player has experienced, essentially looking at what a camera is rendering. But that caused a lot of issues, and they were unreliable. Things were saying they were being looked at behind walls, and it was just not reliable. We ended up replacing it with a raycasting solution, casting a bunch of lasers from the player's face to detect what it's looking at.
Oh, we can't hear you. Is someone trying to speak right now?
Not at the moment. We don't hear Pierce. Uh-oh, he's still going. 1 second.
I think he wanted you to do the slide, Jackie.
Oh, yeah. Sorry, we couldn't hear him for the major challenges slide.
Okay.
I'll continue anyways. So for a lot of the art of the game, we decided to go with a very basically just practical approach to designing a lot of our assets, though we very specifically wanted to focus on this very brightly colored, recognizable toon style, which was very inspired by things such as The Legend of Zelda. So for our main character, Rom, again, also inspired a lot by things such as The Legend of Zelda, with specifically the Wind Waker and other such toon franchises that they designed. We wanted to really create a very recognizable silhouette that would be identifiable from multiple angles very quickly by the player. And so with that, we decided something along the lines of a demon character with the horns and tail, allowing for very quick directional recognition would be a very good idea. And from there, we decided with the name ROM, which we felt would be very fitting due to kind of the coincidental nature of a demon who knoweth things present, past, and future. And for things such as the watch that he wears on his back and also his wrist, we had originally planned gameplay ideas where the player would, instead of having an interface that has a timeline, they would be able to check their watch on the wrist to be able to tell where they are in the timeline. And we had conceptualized ideas for being able to place the backpack down in parts of the levels to achieve certain mechanics. So I did the design and modeling for ROM, as well as the concepting, trying to stay within this relatively cartoonish style. The proportions were intentionally very not quite realistic in how we wanted to give him this very cartoonish silhouette that helped him kind of especially stand out in a medieval castle sort of situation. I had done a lot of work on the normals of the character, spending some time actually learning normal editing specifically to create a very hard and contrasting toon shading along his face, where I could keep the face kind of more of an organic shape so that the silhouette still looks fine, but then the shading was very stark that you see in a lot of 2D or just cell shaded style games in general. And for a lot of our shading, we used a free shader through Unity called Pyomi Toon. I also was in charge of doing the lighting for a lot of the levels, well, all of the levels, I suppose. But so we used Unity's progressive light mapper, which is a GPU or CPU light mapper that allows you to take advantage of a lot of very powerful aspects of your level to create some very nice looking lighting. A lot of it relies on placing down static geometry that is then lit either through baking textures onto it or using light probes, which are demonstrated at the bottom two images. The light probes act to feed information from different points of the level to models that don't use this sort of texture baking system, and they get a approximation of what they should look like based on color, lighting direction, and intensity. And overall, the lighting probe system is significantly more performant than, say, just typical old real-time lighting, which allows us to have some nice-looking lighting effects as seen as our library level while not killing our performance.
Okay, so can everyone hear me?
We can hear you.
Okay. So so we wanted to design the castle to be like easily recognizable and easy to navigate, which is why we went for like the simple like toon shader look. And so we also created models that could like work in a variety of different situations and like have a consistent like aesthetic. And so we decided to make the game have a medieval fantasy feel instead of a like sci-fi theme, because it would be like a contrast from like it would be like a contrast from like a sci-fi like theme that you would expect from a game about time travel. And so our team created simple puzzle mechanics such as like pickup boxes and pressure plates that could be easily recognizable objects that people could interact with. And so you can like we wanted to make it easy to be able to recognize like what objects can be interacted and what can't. For like so for example, if you hover over the box that you can pick up, your crosshair will like change color. And we also like put like footprints on the pressure plate so you know to stand there. Oh, and like we also like color coded the different pressure plates, like according to their functionality. So like I guess red pressure plates can be activated forever. And I think blue pressure plates, you have to put an object on them.
The blue ones are just temporary.
Yeah, they're just temporary. Oh, and so I was in charge of creating this night NPC that would be like a guard that Rom would have to walk around and like avoid running into the line of sight because that would cause a paradox. And so so I like designed the night off based on like the Phantom Knights from Legend of Zelda. And it was definitely a learning experience for me because like I haven't had too much experience in character modeling, and like I never armor modeled like knight armor yet, so I did like research on that. So we weren't able to get it like fully implemented, but we do have like a test scene. So yeah. And then here's our gameplay footage.
Hi, so I'll be narrating over the demonstration. So this will be going over the some of the levels that we have developed so far and mostly finished. It'll be the tutorial, a pressure plate demonstration, and then our library level. For the tutorial, we kind of really wanted to focus on just like our biggest challenge was just how do we teach the player what to do. And we went through a few iterations of placing text around the world, which was a little hard to read. So we decided to kind of revise that and go back and instead have a combination of world elements and UI elements, where UI elements would be much more important things that the player basically has to do in the moment, and world elements would be just informative or suggestive even. We also really wanted to make sure that they were visible, so a lot of them were designed to face the player specifically. Another consideration we took into the tutorial level was really focusing on making sure that it was not too easy to get yourself stuck or anything or cause any paradoxes that you can't get out of. So in terms of puzzle solving, it's pretty simple compared to some of our other levels. And in a moment here, you'll see a demonstration of the time travel mechanic. So as soon as I go in to click on the door, the screen does its little warp effect, and now there is another ROM running around the level, which you will see in a moment. And another feature that we demonstrate here is the memory objects. So what happens is here, memory objects are basically where an object needs to be relatively, not exactly perfect, where they need to be in order to not cause a paradox. Otherwise, again, like here, if these conditions are not met, then you won't be able to complete the level. So in this level, we specifically demonstrate, as I cause multiple paradoxes and rewind out of them using the R key, I have to go and put this cube back, and once I put the cube back, the red tapestry on the pillar indicates it will be open forever, and then I can complete the level normally. This level is our pressure plate demonstration, basically just to act as, hey, this is how you use the temporary pressure plates and stuff like that. The idea here is that we want to design, well, we would have designed levels with the intention of, also here's ROM seeing you, we would have designed levels with the intention of using multiple past selves to achieve a single task or solve a single puzzle, but we kind of had this worry that as we added more ROMs, levels would become significantly harder. And so a specific demonstration here is that so you can see that there are now 2 different ROMs running around, and as the second one goes to complete the other part of the level, it now opens itself up. Uh-oh. I'm sorry about that. My Discord just cut out for a second. Can you still hear me?
Yeah, we can hear you.
Okay, thank you. So this level is our library level, which was one of our much more complicated levels. I don't demonstrate solving the level here as much as just demonstrating the interactability of the ladders, where you could drag them around to position them, and then as the past ROM runs through, they will actually push the ladders around themselves. So the intention there would have been you have to set up the ladders in the pasture yourself and then ride them around holding on for dear life as the past ROM pushes them to the correct location. But other than that, I don't know if you want to add anything, Pierce?
Well, thanks everyone. Any questions? You can try the game at that link. Admittedly, the shaders that we use don't work on WebGL, so the game looks different on the web version. But yeah, open for questions.
What was your
What's
process
your
for
favorite
designing the
level?
puzzles?
I think Pierce and I can both answer this because we both had a little bit of a time with this.
Yeah, Jackie, if you want to start, and then I can say some stuff.
Yeah, sure. So when I was designing specifically, I did the pressure plate level. I was thinking a lot kind of on the flow, how the player goes through the level, rather than specifically kind of setting up the challenge, I guess. I wanted to create basically just I went in with the intention of designing a path for the player to travel through a level and then figured out how to set obstacles along there. So we had the 2 pressure plates at the beginning kind of as a just a test to make sure that the sending a multiple pressure plates would work. The later part of the level was kind of set up with the idea of I wanted to keep the player moving up until the very end so that when there's this natural inclination to hide behind one of the pillars from your past self, you either have a free moment to explore around the level once they run somewhere else, or you're immediately there as the bookshelf opens to reveal the ending of the puzzle.
Yeah, a few of the core level building ideas were like sort of have a certain number of resources that you're trying to work with here. You have to share between other versions of you. So there's only, say, 1 cube, but you have to get it to share with other selves. But the level of concept ideas were just sort of things we came up with, like, oh, you have to use 2 of yourself to open a door, or you get past an area that's locked. It's not locked if you go backwards in time, that sort of thing. Just a lot of the levels actually came together really quickly. The idea sort of, hey, what if we tried this? And then we had to build it.
So, what is your favorite level?
I'm biased. I like the pressure plate level the best, but if I had to pick one that wasn't mine, I like the tutorial. I kind of feel like it has this aside from the UI popping up in your face, it has this sort of, I guess, just the brightness of it being an outdoors level. It has a kind of whimsicality of the beginning of a game, and I like that.
I like the library scene. I think the dark, moody lighting makes it look really interesting.
Personally,
I think the look and the aesthetic of this game turned out really well overall, I'd say.
I'm pretty biased toward the courtyard level that we have. We didn't really show it off in this, but it was the first level that we built sort of feel that worked. But the pressure plate level is also really good. It's definitely one of the better looking levels.
And
I think
personally, I
sorry,
don't
you go,
really
Ben.
have much of a favorite level. I just like them all equally.
Got a question here from YouTube. How are you able to keep your sanity while playtesting?
It wasn't really all that difficult. Most of our levels don't have that many characters running around. Sort of keeping the idea in your head of what's supposed to be happening sort of wasn't too difficult. Sort of think on what's supposed to be happening.
Next question is, how many people did you use to playtest this? It seems like a game where a lot of things could go wrong.
I had I think 5 people on my end try it, and I think that was kind of the most interesting part is just watching people kind of play with this and still more incomplete version of the game and kind of just picking apart all of these things that we never even thought of.
I like this question. What is the most number of other selves that can be active at one time?
I think the most I've ever tested it with was 5. I think I had removed the causing paradoxes part, so I was just spawning a bunch of them and like lining them up in a row. But theoretically, it should just let you spawn however many you want until you can't maneuver anymore.
It will crash
So,
around 60s.
Really?
in a completely unoccupied scene, I would have some just messing around with it, and you could get about 60 before it comes to a grinding halt.
Sounds pretty
Admittedly,
wild.
you can only like squeeze 2 past cells out of a single door, so you're kind of limited at any given level to the number of doors that are in the level.
Yeah, that makes sense. It's kind of built into the design of the level itself. Well, I think we're definitely at time. Thank you so much, Set in Stone, and
Thank you.
all of our teams. Thank you for everyone tuning in online. It's been a fun time. So, thanks and good night.